Thank you all for participating today. A few housekeeping notes before we get started. We will keep this discussion as close to an hour as possible, and please feel free to utilize Zoom's question and answer feature to send in questions throughout the discussion, and we will address as many questions as possible. And a quick note, if you don't know about us at DiligenceVault, we're a two-sided digital diligence platform that facilitates more effective due diligence and information exchange between investors and asset managers. Like everything else we do, today's webinar is meant to be collaborative between DiligenceVault and members of our ecosystem and the broader investment community. If you'd like to learn more about us, to set up a demo with our team, or to get on the mailing list for our future webinars, please email us at ask@diligencevault.com. Now, I'd like to introduce our speakers, Uche Abalogu and Duncan, for our webinar on the science of investing. Uche and Adam, over to you.
So Adam, introduce yourself. Tell us a little bit about yourself.
Sure. So I work at Cambridge Associates, which is an asset manager in Boston. I joined there a number of years ago now in their manager research team. I started out researching quantitative and systematic strategies and macro-related strategies. Then I took over the portfolio modeling and analytics group, where we sort of the quant research group for Cambridge. And then just recently we split that group into two, a risk management function and a data science function. And I now run the data science team there at Cambridge.
Excellent. A little bit about me before we get started. Uche Abalogu. I am currently the Chief Technology Officer at the Private Family Office in New York City. Before that, I was Chief Technology Officer and Managing Director at University of Texas, Texas A&M University Endowment in Austin, Texas. Before that, same role at Harbinger Capital Partners, distressed credit and multi-strategy hedge fund in New York City. And prior to that, 11 years at Goldman Sachs in the prime brokerage hedge fund consulting group and enterprise technology. Today, we are going to explore data and its effects and impacts on investment science. So Adam, what role does data play in investment decision-making at your firm?
Well, it's getting bigger and bigger all the time. And one of the reasons that we formed this group is because we recognized that we needed sort of a pure research function to try to help drive client results from a data-driven perspective. And all of the hard work necessary to make that a reality was something that we felt required a concentrated, dedicated effort. And I would say that, you know, the explosion of data that's hit markets and particularly financial markets in the last decade or so is really opening up a lot of doors for experimentation. And I would say that some of that has been very good but in whole, I would say more disappointing than people maybe had initially imagined. So I think there are some, and we can talk about this as we go on here, but I think that the explosion of this data and the need to deal with it coherently, I think is upon us, and there's a lot of good work being done. Still very early days though.
So since you had to build that data practice, that data science team, what would you say are the best practices for building a data science team?
Yeah, so we've been operational as a team for about 2 years now. And I went through the process of building the business plan and sort of implementing that business plan and sort of marketing it to the leadership team at Cambridge. And so I do have some perspective on what I think are some good ideas when you try to do this, particularly if you're not yet started. These are some things that I hope will help you as you think about going into data science. I think there's a big, this idea that you need a team of PhDs and get them in there and somehow magic will happen. That is not an approach that I would recommend. It's not the way that we do it. And you probably almost for sure don't need a large team of PhDs to sit down and try to make magic happen. So a much more sort of a smaller approach and something that I think leads to less disappointment over time is the following. I think you need basically 5 core functions to build a good data science team, a good working data science team. One is you're going to need data engineering capabilities. And when I say data engineering, it's a very intentional use of words. Data engineering is a science almost of it, in and of itself. But these are folks that are going to help with ingestion and curation of data sets, both internal data sets and external data sets. It is a full-time job. And one of the mistakes that I think that people make is they hire data scientists and the data scientists get in their seat and then they end up spending two years plus doing data engineering. So focus on getting someone or some collection of people who can focus strictly on data engineering. 2, you're going to need subject matter experts who are also technologists. So these tend to be quant heavy people who have deep subject matter expertise and understand the kinds of problems you're going to be working on, and are also have both feet on the ground with respect to technology and what can and cannot be done with the current sort of technology. 3, modelers, people who understand how to model things appropriately, people who have a decent knowledge of what models are appropriate for what tasks and what some of the shortcomings of those things are. And sometimes the subject matter experts and the modelers are the same people, but you are going to need some modeling capabilities for sure. Next, number 4, I would say you're going to need deployment and / cloud engineers. And I know we're going to talk a little bit about that later, but once you get some insights going or you get something that's useful, it's really helpful to have people who can help you with the deployment and how you're going to bring that to your audience and how you're going to maintain it and so on. Another big time suck for your data science team is maintaining things that you've deployed. So you need to think carefully about that, and I strongly recommend cloud engineers for this task. And lastly, it's sort of an overlooked thing in many contexts, is you're going to need storytellers, data visualization people who can put these insights together in a way that is attractive and coherent for your audience. And also along with that role is some advocates, and we call them developer advocates, but basically people who can interface with your audience and get feedback for the teams and can do that in a very good way. That's a really important job because a lot of good technology gets deployed and without the right advocates in place and the right storytelling in place, sometimes it can just fall short of what people were expecting.
It's great. I mean, that jives with my experience. And one anecdote to add to that is I served on the advisory board of the Macomb School of Business at the University of Texas at Austin, and the graduate students and undergrad program there had such a rich data science content that the graduates we got from that program, both interns and others, were astoundingly good. So there's a lot of talent floating around our local universities because this is a hot topic right now and the kids are into it and they're doing great. So what would you say the impact of data and automation on selection, monitoring, and reporting is? How have you put that for your?
It's a great question. I think that, I mentioned some disappointment, and I also mentioned some encouragement. And I would say, look, if you think that you can take a bunch of prices and, feed them into some deep learning neural net or whatever, some machine learning model, and you're going to get great results, I think that you will be disappointed. The signal to noise ratio in financial markets and the stability of financial markets in terms of what drives price action is so unstable that just plowing, scads and scads of price data and other information into some neural net is going to lead to disappointment. Having said that, when you think about the impact like on asset allocation, right? I think that Marco Lopez de Prado and Marat Maliboga, who extended some of those frameworks on, coming up with ways to derive portfolio allocations that don't involve inverting the covariance matrix. That is something that uses machine learning technology that is very, very interesting. And I hope that more people will experiment with that and see how the stability of those things are. So that's a very good example in asset allocation of some work that I think is fantastic. In terms of manager selection and investment selection, your boss is going to want you to build some machine learning model that can pick the best funds for the next 5 years out of sample. That's what sort of everybody wants to do. And this is a common thing that I see. Sorry, so there's a question to repeat this. The Marcos Lopez de Prado is has written a ton about that, and Marat Maliboga is the other person, those two authors. We can put those in the notes. In terms of selection though, I think that this is a common problem where people specify what I think is the wrong objective function. Like if you specify an objective function that says, hey, pick the winners out of these 100 managers for the next 5 years, that's what we call on my team the Nobel Prize problem. Like if you solve that problem, you're probably going to win the Nobel Prize. This is the wrong objective function for you to set out for, because you're just going to be disappointed in your ability to achieve that. So I think it's important when it comes to exercises like selection to change your objective functions to something that is achievable. For example, I might be able to train a model to pick funds like you pick funds, Uche. So I can look at your past behavior and I can train a model that can replicate Uche's behavior. That is a much different problem than picking the best funds in the next 5 years out of sample. One of those is very stable and has some properties that we can hang our hat on, and the other is just very noisy and difficult. So, so beware of the Nobel Prize problem. I would also say beware of the biases that can come when you train models. So if I train a model to pick funds like Uche picks funds, then the assumption there is that I like the way Uche picks funds. If I don't like the way Uche picks funds, then this machine learning model is just going to scale up Uche's bad process. And so you want to be pretty sure that the thing that you're training is injecting scale into something that you like and that you want to get more of, because all of the bad biases, models can learn those just as easily. On governance, so a big place, and I think if you look at firms like Two Sigma and Renaissance and others, a lot of the big bang for the buck that they got out of machine learning so far has been in the back of the house with respect to governance and compliance and contexts like that. And we would agree strongly with that. We think that governance and monitoring are a great place to deploy machine learning technology. A good example, well, let's just take the following quick example. Suppose you had 25 investments in the average client portfolio, and you had 10 metrics that you cared about and you wanted to keep track of, and you had, let's say, 15 clients, which is a very sort of typical setup. 25 or so investments, 10 metrics I really care about, and maybe 15 clients that I cover. That's 3,750 metrics that you need to keep in track of across your sort of client portfolio. That is a just insane amount of stuff to keep track of for any human. And if you do 20 clients, you're up to 5,000 metrics. And so it's very clear to us that if you want to, a good place to deploy technology here, if you want to keep track of these things sensibly and add some priority to your governance, is that you can deploy things like anomaly detection systems that basically monitor these metrics for you behind the scenes and alert you when things are looking weird. And how do you tell when things are looking weird? Well, that's where the machine learning and some of the science comes in, is building those frameworks so that they don't produce too many alerts and don't produce too few alerts and so on. So that's like 3 places where I think some interesting impact is being seen. And most of it does not involve sort of deploying machine learning models to prices.
Excellent. I'm sure a lot of the big houses are already doing that, and some of that talent and practices will be spilling out onto the street in due course. That gives us a good segue into technologies adopted by endowments, foundations, pension plans, and investment consultants. What have you seen in your travels?
Honestly, you know, I don't think that things are very far along. I mean, those of us who follow technology tend to hear about all of the great things that are happening with the big tech companies. I saw something the other day where the census, you know, in its questioning, produced a result, and there were some issues. Like, it basically ignored a lot of the big public companies where I think you see a lot more technology being deployed. But in your sort of smaller private companies, you know, I think something like less than 10% of small private companies have some form of machine learning or AI in production. Something like 9% they quoted. So this is like basically nobody or very few people have something going on in production outside of the big public companies. And inside there, the numbers range, I think, from somewhere in 20 to 30% range. And, you know, people think that there'll be a lot more as we go, but it's certainly not like 80% of people have machine learning or AI in production or have well-developed data science teams or data capabilities. And so, so I think what's actually happening, you know, from a machine learning perspective is pretty small. And I would even say that in our travels, you would be surprised, or maybe not, at how difficult even simple things can be. You know, well-curated data sets that are ready to work on are just not laying around waiting for you to analyze them.
Yeah.
It takes a tremendous amount of work, particularly like in private investment space. Even just the collection of the inputs is no trivial task. You know, it is not easy to get timely information about private investments, and that's something that our clients care a lot about. So, so I would say it is very early days, and that sometimes even doing simple things at scale can be quite challenging.
I mean, when you think about it, these days, Google, Amazon with AWS and Azure have easily adaptable plugins on their cloud platforms that will allow for a lot of capabilities. And the kids at college right now are playing with that and building some really cool learning models. And
Absolutely.
I personally believe that if organizations would give their employees a little bit more playtime to go build systems that can work, they would come up with some very good models, but since everyone's running lean and mean, it's the exception rather than the rule.
Agreed.
So as we hire these fresh grads, we might start seeing things change in that domain. Moving on to practical considerations, who would you say are the users of and applications for, artificial intelligence and machine learning? What would you?
Well, I think, everybody, there's a couple things here. First of all, let me just say, like, one of the things that we did at Cambridge Associates just last week, we had a FedEx Day. And a FedEx Day is a day where everybody gets the day off. You have 24 hours to work on anything you want. And at the end of the 24 hours, you your team presents whatever it is that you created. And there's been a few examples.
An internal hackathon, right?
It's an internal hackathon, and it's super fun. The teams all love it. And some of the stuff that comes out of there actually is really inspirational and even makes its way into production systems. Say, oh my gosh, that's really cool. Let's work on that, and the enterprise can benefit. So I do think that more companies should allow their companies to have this day. It's a lot of fun, and you would be shocked at what people come up with and what they do. It's really, really, it's great for innovation, and I think more companies should do that. In terms of like users, whether it's public investment people, private investment people, macro researchers, I think that there are use cases all over our firm where you can have great benefit and even get scale from a well-formed data science function. In publics, like I mentioned, anomaly detection is really important. Having machines allow our research teams to monitor existing investments, and then building machine learning models that one of the troubles that you'll have in any of these organizations is that the sourcing of new investment ideas is a very human process. And if you ask yourself, well, gee, like, how did we find these investments? Usually you find like it's some random kind of, oh, I went to a conference, I bumped into this person I met, and that's how we found them, or whatever. Our investment researchers tend to be extremely talented. We just don't have enough of them, and they're unable to sort of canvas the entire universe. And so if you can train machine learning models that select funds in a way that's very similar to how our researchers, you can bring more of the universe to their attention, and in so doing, provide more target-rich environments for them to research. That is a very critical thing. So that's on the public side, and we have good or better data availability there to support those activities. On the private investment side, there's also a ton of potential there, and in particular, trying to answer questions about what do you think of the money that I put in the ground a number of years ago. Let's say, if someone said, what do you think about vintage 2011, such and such, would you have a way to put together a decent forecast for that, given everything that's evolved since 2011? That might be a little old nowadays, but let's say 2017 or something. And coming up with ways to inform those forecasts using data, I think is really helpful, so that you can ask the model, say, hey, model, what do you think about the performance of those things? So I think there's lots of good use cases there. On the macro side, there's certainly sort of a wedding there between the private investments and the macro researchers in terms of there's some really interesting work. I think MSCI's got some good stuff going on now, casting private equity returns, which is basically trying to take private investments and wedge them into classic risk management frameworks using higher frequency data. Those are all really interesting things where high frequency data sources can help inform those that risk management function. So I would say, there's almost no place where, quality data-driven insights can help with scale and prioritization of activity.
Would you lump natural language processing into that mix, or?
I would. We're thinking hard right now about how to deal with unstructured data. We're swimming in unstructured data, and the amount of unstructured data that we have relative to structured data is much more. We have much more textual data than we do numeric data when it comes to investments, and being able to do that deal with that sensibly is really important. For example, the metrics that the example I gave earlier, where you have 25 investments, 10 metrics you care about, and 20 clients, that didn't even include monitoring all of the meeting notes, textual information that comes off of these investments, filings, and so on. That's not even included in those 10 metrics, right? So a classic problem that people have is, listen, I have 25 investments. I have a research team that's out there writing notes. I just need the 3 bullet points for each of those 25 managers. And I need them right away for this meeting with the client. That function itself is super difficult. It's very manual, and you have to go and look up the notes that were filed and then try to read it and extract some things. So there's some great stuff on the horizon, and audience may be familiar with GPT-2, GPT-3 now, where some massive summarization capabilities, even text generation capabilities are really coming to the fore. We've spent a decent amount of time on robo-texting. So there's nothing more sort of mind-numbing in my view than translating some performance table from a manager letter into a comment that goes into your system. Like, that's just horrendous, right? A computer can easily look at the entries in that table and generate sort of text that summarizes what's in that performance table. And we really shouldn't have humans needing to deal with that sort of activity. And so robo-texting, being able to take a set of numbers or text summarization, these are big opportunities to inject scale into our businesses.
Yeah, text, translation is transcribing the other way around has become really good, and those systems really make mistakes these days. So, we have to get past the skeptical humans and the bosses to make that happen. But that day's coming.
For sure. I mean,
Yeah.
if you look at the economic releases on Bloomberg, right? So at 8:30, when the economic data hits, right, instantaneously there's a note on the Bloomberg terminal about what just happened from that economic release. That is entirely robo-generated. Like, some human didn't just have that teed up and ready to go and hit go. No, that was someone who took, or that was a computer that ingested that economic release and generated boilerplate commentary from the results. And so this is the kind of thing that can really lead to scale. I think from our view, we'd rather have our human researchers and other investment professionals reading and absorbing that data and offering their own insights on top of that, rather than generating that, relatively boilerplate commentary from a performance table or something.
Okay. So moving on to a slightly different topic, what investment structures have you seen that incorporate a data-driven approach?
Well, I think we've talked about most of what I've seen, right? So, I think that there are some great opportunities for anomaly detection frameworks. I think there's some great stuff to be done in unstructured text processing. I think that there's some great work that can be done in forecasting. there are all kinds of forecasting contexts where I think good data science teams really, really help out. This can be anything from cash flow forecasting for the firm to forecasting results from private equity investments to forecasting unanticipated changes in AUM at a manager. All of these things are great forecasting problems, and you just need. And by the way, I would just say one of the people that I really like in data science is Matt Taddy, who used to work at Amazon and has written a great book called Business Data Science, if you're not familiar with it. But Matt Taddy has a great perspective, I think, on what it means to do data science. And he even wrote a pretty famous paper with some co-authors about quantifying or trying to quantify what's happened to innovation in this country. Like, have we seen a decline in innovation? And this is a very tricky question where it's not obvious how you quantify or turn innovation into a sort of a numeric thing that you could plot and see whether it's gone up or down over time. And that, I think, is, he and his team and their approach to, that's where the real value of a data scientist is taking some nebulous, difficult to think about concept and turning that into a framework where you can actually get some insight into what's happened to innovation or some other thing you care about. And so that, I think, is where you get a lot of bang for your buck. And I would, for the young folks out there, I would say that, training yourself up on lots of different machine learning, techniques and so on and so forth is somewhat good, but you need to understand those models and those frameworks. But it's ever more, a lot of the stuff has become, auto ML. And by the time your problem gets to a point where you're ready to do the machine learning part, as you mentioned, Uche, AWS already has tons of, you could just send that off to an automated machine learning framework and it'll deal with all of that. And so the hard part of the problem, and honestly, my team, we spend very little time, debating and tuning the machine learning models and using cutting edge technology. It's getting to the point where you're ready to deploy a machine learning model that is the bulk of the work. And so, having good scientists who can think about problems creatively and then finally bring those to modeling frameworks, I think, is the real challenge.
Yeah, my team and I at UTIMCO did a fun project with grad students at UT to run private equity cash flow forecasting for the year over the summer, comparing the results from their AI model and analysts. And it was a very interesting result. While they could only save about $1 million from the results, but you could see the promise if somebody was dedicated to that full time and you ran that over a couple of years to get a proper data sample. But the potential is immense. It's immense. So
yeah.
Talk about cloud. I think we have a good segue into the role of cloud adoption in building scalable data science frameworks. I mean, that is a wide open and very affordable area right now, would you say?
Yeah, it's good that you mentioned that. I mean, we are heavy users of AWS. I'm a big fan, a big supporter of what they're doing. Things like the S3, the simple storage service, the simple email service, SES, the simple notification service, just between, sort of S3, SES, Lambda, which is their sort of lightweight serverless framework. If you just had access to S3, SES, Lambda, and maybe SNS, you can do a ton. And that is like a small fraction of everything that AWS brings to the table. Other, Azure and Microsoft are also, coming good, and Google Cloud is coming away. But whatever service you pick, I think that making use of those is really, really important as you think about building out your infrastructure. And I would just take a minute to comment on what I call the sort of app culture. When you talk to users and you say, hey, you just talk to them about what problems they're considering, what data problems they have, you always hear things like, oh, it'd be great if we had an app that could do X. Oh, it'd be cool if we had an app that could do Y. And this idea that, and a lot of this, I guess, comes from the iPhone and others, but, I think you should really, really pause before you build an app to do something. And most people, like, if a PDF will suffice, don't build an app. And if an email will work, don't build an app. There is so much that comes with maintaining, deploying, and just sort of servicing an app. All the UX programming that has to be done, and it's just a very, very difficult thing to do. Yet we often first default to, hey, let's build an app to do this. And I would encourage teams, particularly smaller teams, to avoid at all costs, unless you really, really, really need an app. I would investigate other delivery channels for your data science and your insights, because apps come with just a ton. My team rails very hard against me whenever I mention the word building an app. They come down on me pretty hard. So apps are better for enterprise teams, and I encourage data science folks to look for more lightweight ways to deliver. But absolutely maximize, if there's something that is usable and available in a cloud framework that you can make use of, absolutely use it, rather than doing that on your own. I'm thinking mostly about server maintenance. Server maintenance is a super drag. Not only do you have to maintain your app, but you got to maintain the servers that live on the app. And if this isn't an enterprise application, then your data science team is left to deal with all that. And lastly, I would say beware your SLAs. And when I say SLA, I mean service level agreement. When you spin up an app using Shiny or some other framework, and you put that out to your consumer base, you need to contemplate, like, what sort of service level are you promising those people? What promises are you making to the audience when you put that app out there? Look, I have this app and it does this cool data science thing. Okay, well, is this app going to be up all the time? What if the data inputs fail? Like, how fast will you fix it? Like, what promises are you making when you do all this? And I think if you spend some time thinking about it, you'll realize that emails and simple notifications or text messages or other lightweight ways to get the insights to your consumer base is preferable than building something like an app or something more heavyweight.
So what advice would you have for managers that are listening in terms of how to enable and encourage the data science practice in your shops?
Well, from a manager perspective, there's a few things. One is timely reporting of information. I think that is a big thing. What we struggle with is getting the data from the managers in a timely fashion and making sure it's consistent, making sure that process is automated and has checks around it, automated checks and so on, is super important. Like, one of the first things that my team did is we built a bunch of checks on the data that comes into our central data collection platforms.
So automated data validation rules.
Automated data validation. It's a huge, huge thing, and something you should spend a ton of time on. And looking for all kinds of weird things, anything that is weird or isn't coming in time and so on. Having alerts set up for that. And so really working on your data ingestion model, and this is where I think managers and some of the larger platforms can really help, is making sure that their data is ending up in the right place at the right time is really, really important. This is super true in private investments, where I mean, what does it mean to report on anomalies on data that was 6 months ago? I mean, how helpful is that? And this can really easily happen with private investments where the lags in data are high. Additionally, don't be surprised, like when you try to form cross sections of managers. So if you want to look at managers in the cross section, and 40% of the universe hasn't reported a return for this month, well, now you've got to go back another month in order to get the cross section filled out, or you have to leave them on the cutting room floor. It can really hurt your cross sectional analysis because you don't have good data availability. So I think working with the managers, a big thing that's come up recently is with our, a lot of the ESG data, a lot of the diversity data that we're interested in these days. There aren't really good sources of this, and you will find yourself most likely having to survey managers and collect this information and build these data sets, as you mentioned, Uche, build those data sets from the ground up. And being very careful. I think it's good to engage your data science team on how you're constructing those surveys, how often are you collecting that data, and making sure that the questions you're asking are suitable for downstream analysis, and that you're not collecting a lot of unstructured text information that's going to have to be processed by a human or dealt with in a more difficult way. So there's lots and lots of places where I think smart data professionals can really help and make downstream life easier when you're building out some of these unique data sets that don't really exist yet.
Excellent. We have some questions here, starting from the top. Some folks want you to repeat the name of the person you were talking about on asset allocation.
Yeah. So the asset allocation work that I'm referring to is Marcos Lopez de Prado. He did some very, very interesting pioneering work on hierarchical clustering and its application to optimal asset allocation. So basically, he noticed that the big instability with classic mean variance approaches to asset allocation involve inverting the covariance matrix, and pretty much every solution that you look, even all of the modern machinations of this, all involve inverting the covariance matrix, and that leads to some very unstable results. And people have probably heard that that's an error maximizing process. So he said, how can I use modern machine learning to get to an asset allocation, an optimal asset allocation, without inverting the covariance matrix? And he's written a lot about that. He's also written a lot, by the way, just on machine learning and finance. And you should look up his books. He's got a new book out, I think, Machine Learning for Asset Managers. But those are great books. He's been a big pioneer on that. And then a friend of mine, Marat Maliboga, has done some work on extending those frameworks to account for some of the shortfalls. And his name is Marat Maliboga. He works for Efficient Capital out in Chicago, but he's done some great work as well.
Great. Yeah, we'll probably have to transcribe that so that we can share this with the audience after the event, so that they have the correct spellings as well to go search.
Yeah, sure.
Another question we have here is, how do you rank your data across price data, macro data, metadata, as well as emerging data fields around diversity and sustainability based on quality, timelines, and cost of data acquisition? That's a project in its own.
Yeah, that's a mouthful there. I would say just broadly that timeliness across all, but much of there's lots of high frequency economic data. There's lots of price data that's available in a timely fashion. But as you come away from what I would call sort of trading desk type data and get more into the the type of investments that our clients make, the timeliness starts to become much more of an issue. And the work that we've done is even some of the best data vendors that we have, aren't able to get the data faster than we are through our processes. And so, so collecting hedge fund data, for example, is just a naturally slow thing. And I would say that, in terms of quality and availability and things like diversity and ESG, it can be really challenging. There is some stuff out there, but that can be, some of those data sets just don't even exist. You may want to be scoring portfolios from a social, from an ESG perspective, but you don't have all of the positions underlying. So how do you score a portfolio where you don't have full access to underlying position information? It'd be really difficult. So all of those are challenges, and we spend a ton of time. I'll just say, even in your own internal data, like let's suppose that you have some investment committee and they've been selecting investments for years or putting labels on investments for years, like this is good, this is bad. Investment committees change over time, and people are always futzing with the system and the rankings and the ratings and, oh, let's, make a change this way. So every 5 years or so, you might have a change in the way that the committee is actually recording the investments. So when you look at it, you might have 35 years worth of labeled data, but the meaning of the labels has changed every 5 years. So it's really, really important to spend a lot of time understanding, like, are these labels really the same? Is the label from 2001, this good label, is that the same as today's good label? And in many cases, the answer is no. And so you find yourself with actually much less usable data in the current context.
Thanks for that. Next question. Do you suggest any good material or examples on risk modeling associated with private investments and AI ML?
No. Unfortunately, we've done some work on building forecast models for things like private real estate and some things like that. I think that there's some classical multi-level and hierarchical modeling that you can do with respect to those things, sort of controlling for vintage years and controlling for investment type and so on. But you're just not gonna get, the answer is no when it comes to just sort of, I haven't seen any great frameworks out there, the AI ML frameworks out there for private investments. I do think that the nowcasting, if you want to, a big challenge for risk management and private investments is how do you marry the liquid side of your portfolio with the illiquid side of your portfolio? And people have this desire to kind of get those things together and risk manage them in like one coherent framework. And that turns out to be challenging on a bunch of different fronts. And sort of de-smoothing those returns and treating them that way and wedging them in with the other things to get a read. It's a really, really challenging process. And given your limited ability to make adjustments to that part of the portfolio, you might question whether you want to do that in the first place. So I don't have great answers for AI ML as it relates to private investments, but those are some of the challenges.
Would you say Marat Maliboga's work is a good place to start to help think about it, or Marat's?
Marat's done a ton of work on forming CTA portfolios, and he works at a CTA, and so he's done a lot of work on constructing CTA portfolios, and I think I'm a fan of a lot of the stuff that he's done, but that's not in the realm of private investments, and I don't even think that Marco's DePrado's work has been it covers private investments. And so private investment is one of these strange things where even agreeing on what the return we just earned can be challenging, let alone fitting machine learning models around that. So yeah, I would encourage great caution in trying to fit machine learning models to private investment data, and I would spend way more time just understanding the problems and using classical modeling and some simple EDA before I launched into all that.
Yeah, I guess the conundrum in our space in the investment world is a lot of our data tends to be proprietary. So even where we have good internal data, we cannot share it. And
that's right.
When you look at data.world and the data sets they're building out in the broader community, it's mouth-watering to think about what you could get if you applied that data.world model to the investment space. But we can only dream, right?
Very well said. Well said. Yes.
Yeah, Calpos could help if anybody from Calpos is listening. But
yeah.
Okay. So how do you combine the data you get directly from your managers with the data you buy from data vendors? What are the roadblocks?
Yeah. So there are sort of timing issues. You need to be very careful about what data was known when. We generally don't have too many issues lining up our vendor data with our manager data because, you know, the frequencies of the reporting are pretty low, and we tend to have observations, you know, for the vendor data at the same time or relatively close to the same time as we have the observations for the manager data. So I think this gets more challenging when you have higher frequency contexts and you have lots of alternative data sets. And then I think you need to be really, really careful. It's very easy when you're building models to bake in a look ahead bias or use data that you didn't really have or wouldn't have known at the time. And so this is where I mentioned at the head to have modelers. Like modelers will catch these sorts of things. Another thing that I would say is that date math is the most of the bugs and trips that I have ever encountered in my entire modeling life. I would say the vast majority of them are around date math and date machinations. And it's very easy to be lackadaisical about dates and times, time zone differences, and so on. And those things inevitably, particularly when you get to deployment, those things inevitably come back to haunt you. So be very careful about that.
So we have a question from Rachel. Hi, Rach. What metrics would you suggest initially focusing on providing to your firm leadership to try to get more support buying for data technology projects?
That's a great question, and something that I thought a lot about. I think it's good to point out the sheer enormity of the tasks that you're asking your humans to do. So a lot of what I pitched was a scale argument. Scale is a challenge for our type of business when you're building custom portfolios tailored to each client, and you know our investment teams are inevitably running tight from a personnel perspective, and you just have to help these folks get some scale where the scale doesn't come from hiring more people to do the activity. And so as I mentioned, I mean, highlighting 10 metrics is not a lot of metrics to care about. And 25 investments is not a ton of investments to have in a professional portfolio. And 20 clients or 15 clients is not unreasonable. And that when you do the math, it's just like, how am I supposed to keep track of all this stuff? Think about this too. When we do governance on portfolios historically, we would just take the list of things that need to be governed. Let's say that you need to call all of your managers every quarter. Well, how do you decide who gets called first and who gets called last? Is there any way to prioritize this governance activity so that I'm just not going linearly through the list, but I'm actually putting some priority? Like maybe some of these funds are actually on fire and I really need to call them and have like some senior oversight here. And the bottom section of these are totally performing within expectations, and we could just do we can deal with them later. How are you going to know that unless you implement some of these types of frameworks where you can set those priorities? So improving your governance and your monitoring is a big thing. Trying to get scale so that, I always ask the question, if our investment directors are managing 10 to 20 portfolios, why isn't that number 50? Like, is it, or why isn't it 30? And it's probably because we have to scale with humans at the moment, and that we're not using technology in a way that allows us to manage these portfolios with less human energy.
I think that's all we have time for today. I think, so what would you, in conclusion, what would you say to close out the conversation today? It's been great.
Yeah, I would say to summarize is that you can do a lot with a little. You can be very effective with a small team. You do not need a team of PhDs. You need a team of people who can upskill quickly in lots of different areas. This idea that you need to buy a huge team of expensive folks is not really true. I would say keep it simple. I would say really question yourself before you build applications that require more support. And I would say leverage every bit of cloud technology that you can. It really helps industrialize, and you can do a lot with a small team.
Okay, well, thanks very much. It's been a great conversation, and Bill, over to you.
Great. Thank you very much, Adam and Uche. That was a terrific conversation. Really appreciate all of your thoughts and insights on this topic. We will be sending out a recording with key takeaways and the names of the professionals in their research that were discussed today, and we will send an email notifying you of when the recording will be available. Before you go, please take a look at the poll on the screen, which will also be included in the takeaways that we send out. And most importantly, we want to thank you for your participation and for joining us today on our webinar. Have a great rest of your day. Thank you.